Good morning, students. Today, the topic of discussion is solubility. And in solubility, first we'll take up solubility of solid in liquids. Solubility क्या है? What is this? Solubility is the maximum amount of solute in grams which can be dissolved in 100 gram of solvent at the given temperature to form a saturated solution. That is solubility. Now, solubility of solid depends upon number one, nature of solvent and solute. It goes by the saying like dissolves like. That is, a polar solute is soluble in a polar solvent, and similarly, a non-polar solute is soluble in a non-polar solvent. For example, NaCl. NaCl is highly polar, it's ionic compound. It is soluble in polar solvent like water. Similarly, non-polar solutes are soluble like naphthalene. Non-polar solutes like naphthalene are soluble in non-polar solvents, benzene, etc. Second factor on which solubility of solid depends is temperature. Solubility of solid is directly proportional to temperature. As the temperature rises, kinetic energy of molecules increases, that increases solubility. Okay, that's it for solubility of solid in liquids. Second, we'll come to solubility of gas and liquid. First factor on which this depends is the nature of gas and liquid. For example, gases like O2, H2 are very less soluble in water at a given temperature, whereas gases like CO2, NH3, which are capable of forming bonds with water, are more soluble. So it depends upon nature of both gas and liquid. Second factor on which solubility of gas in a liquid depends is temperature. Solubility in this case is inversely proportional to temperature. Same reason, as temperature increases, kinetic energy of dissolved gas molecules increases and gas particles tends to leave the solution. So solubility will decrease. Third and most important factor is pressure. Solubility of a gas in liquid is directly proportional to pressure. Look at this diagram. It's a liquid here. Gas particles which are present above this liquid layer. Consider it as a closed system. So now gas particles have been dissolved. So if we increase the pressure, then suppose the piston is pushed to this point. These gas particles, which originally occupy this volume, where will they go? They'll mix up with the solution. So concentration of solute particles will increase. So solubility of gas in liquid is directly proportional to pressure. This is the statement of Henry's law. What Henry law states that solubility of a gas is directly proportional to its pressure. Okay. Second statement of Henry's law is that partial pressure of a gas is directly proportional to its mole fraction in solution. That is, partial pressure of gas in vapor phase EA directly proportional to XA, that is its mole fraction. PA is equal to KH into mole fraction of gas A, where KH is constant of proportionality known as Henry's law constant. Okay, then there are certain limitations of this Henry law. Number one, this law is applicable only when pressure is low and temperature is high. That is, the gas is ideal. The second limitation of Henry's law is the gas should not react chemically with the solvent. Okay, these are two limitations of Henry's law. Next come to applications of Henry's law. First application is carbonated drinks. Carbonated drinks are packed under high pressure. You must have been observed this thing in Coca-Cola, Pepsi, Epifizz. These drinks are packed under high pressure to keep carbon dioxide, or I should say more carbon dioxide inside the drink. Second application, in case of scuba divers. Scuba divers carry oxygen cylinders. Those oxygen cylinders contains more oxygen and less nitrogen as comparative to normal air. Reason for this is, as the depth increases, gases become more soluble in blood. Oxygen is used in metabolic activities, but nitrogen that remain unused. And when depth decreases, that means scuba divers when rises, solubility of nitrogen decreases in blood. This leads to very painful situation or a disease called bends or decompression disease. For this reason, concentration of nitrogen is decreased in cylinders of scuba divers. Instead, the concentration of oxygen is increased and some amount of inert gas like argon is added into their cylinders. Because with pressure, solubility of argon or any another inert gas does not change much. Third application of Henry's law is in case of high altitude climbers. At high altitude, partial pressure of oxygen gas is low. That means less supply of oxygen to lungs and all parts of the body. This causes dizziness or not clear thinking. This leads to a disease known as anoxia. After Henry's law, students will discuss types of solutes. Generally, substances or say solutes are of two types, volatile and non-volatile. A volatile substance is one which is capable of forming vapors at given temperature, at normal temperature say. And a non-volatile solute is one which is incapable of forming vapors. Examples of volatile solutes are say ethanol, acetone, naphthalene, and non-volatile solutes like sugar, glucose, which cannot form vapors even at elevated temperatures. Okay, then there is a term vapor pressure. Consider this beaker containing solution of a solute which is volatile in nature. That means some of the vapors are present in the beaker. It's the vapor phase. This one is liquid phase. Now, what is this vapor pressure? Vapor pressure is the pressure exerted by the vapors on the liquid layer when in equilibrium with the liquid phase. That is known as vapor pressure. Again, what is vapor pressure? Vapor pressure is the pressure exerted by the vapors of the liquid on the liquid layer when both phases are in equilibrium. That is known as vapor pressure. Vapor pressure of the given liquid depends upon two factors. Number one is nature. Nature means some liquids or solids say, are more volatile, just like acetone is more volatile than water. So vapor pressure of acetone will be more than water. Similarly, second factor on which vapor pressure depends that is temperature. Back to this diagram. Suppose temperature of this system is increased. What will happen? If temperature increases, kinetic energy of these molecules will increase. They'll tend to leave the liquid and get into vapor phase. So number of vapors bound to increase. If number of vapors increases, that will exert more pressure on the liquid layer. So vapor pressure will increase. So students, vapor pressure depends upon two factors. Number one, nature. Number two, temperature. These 2 points are important. Memorize them. Next is boiling point. Boiling point of a liquid is the temperature at which its vapor pressure becomes equal to atmospheric pressure, roughly 1 atm. Exactly at sea level, 1 atm. So again, what is boiling point? Boiling point is the temperature at which vapor pressure of the substance becomes equal to atmospheric pressure. That is known as boiling point of that given liquid.